Hey there, grade 10s. I'm going to write my conclusion. This is completely live and unrehearsed. I do not know what words I'm going to say. Let's see how I do it live. So we have our graph. I have over here my wonderful trusty lab guide and have a conclusion right here of the things I'm supposed to say. And if I click here, it takes me down to a sample conclusion. Explain your results using scientific reasoning. This should relate to the scientific reasoning stating hypothesis or background information. To be honest, I was being pretty quick here. I didn't have too many words. I should have explained what these words, what these letters mean. A is amplitude, D is distance. And I could have explained a bit more, and I didn't. That was bad. Bad, Mr. Fleming. Let's come down here. Conclusion. And let's go down to the sample one here. Okay, oopsie. Let's try this again. The data, and let's bold this. The data shows, what does the data show? Okay. As the distance increases, right? The distance increases. The sound amplitude decreases, it's obvious, but does it decrease inversely? That is the key. Because I can't, let's see the prediction graph. It looks similar. It does look similar. What does an inverse graph mean? An inverse graph means y equals, why do you give me a big Y? Come on, don't be like that, Google. 1 over x. Or I could write that as x, I'll see another line. Y equals 1 over x, the same as x, how do I superscript? To the minus 1 format tools. Where's my text? Superscript. Good. So that means the power should be minus 1 if this is inverse. So the actual power means something. And that's why Logger Pro is so awesome. Let's decode this a little bit for you. Let's zoom in, make this easier to read. A equals, that's A for amplitude. This is a code, there's a letter A, that's a B, that's a distance. So A times D to the B. So B is the power. A is just some number. It could be any number, doesn't matter. So B, the power here is negative 1.233. And if it's perfect, according to this one, which I made really small, if I can zoom in here. I'm not sure if it zooms in the video, who knows? The D, well, D's is minus 1. Because, well, that's what it is, inverse. It doesn't say it, because that's what inverse means. Okay. So the sound decrease, I'm going to say approximately, let's go back to 150. Approximately inversely. Now I'm going to justify the word approximately. An inverse function has x to the minus 1. I'll superscript in a second. And the results show a relationship of a varying. How do I get a vary symbol here? Insert. Should be a symbol somewhere. Special characters? Yeah, why not? Can I search? Yes, I can. Inverse. Where's this? No, it's proportional. That's what I want. I want the word proportional. Proportional. Is that it? Yes, it is. A, well, give it to me twice. A is proportional to 1, to D to the power, what did I say? I forgot. 1.233, negative 1.233. Let's put a period at the end of that sentence. Then we're going to talk about this a bit more. I know it's your command period. I'm pressing it right now. It doesn't work on my computer. That's bad for me. I know it works for you. Sorry, you gotta wait for this. Too bad. And let's do this one too. Here it is. Good. And then the ratio of, okay, so this is pretty close. A function, okay. The shape of the graph appears to match the hypothesis, and the power of negative 1.2, let's round it off, or 233 for now, is close to the theoretical power of negative 1. Let's look back at this lab guide. Where is I? This is a linear one because it's a different, that was a linear pattern, but the words might still help us. Okay. Oh, so we need to relate this to theory. Well, we are right now. That's pretty good. What else do we need to have? Mathematical reasoning. I did that. Relate to a known formula if possible. I have that. Make sure my reasoning is coherent. Some people write too much. We don't need to write too much. That's pretty good. Use all appropriate scientific vocabulary to support your explanation. I use the word inverse. Theoretical power. That's pretty good. We should maybe explain this a little bit. So what I'm going to do another search for Google hyperphysics. I know what I want. Hyperphysics, intensity of sound, maybe? Of sound and distance. Let's see what happens. Inverse squared. Oh, but I don't want inverse square because this is for intensity. So this part's not true because we have amplitude, and there's other things that this isn't telling us. But basically, we understand that if we go further from the source, the power is spread out. We need to keep this fair for grade 10s. Grade 11s can understand this in physics class, but you're not grade 11 physics students. So what can we say? This relates to, but not the shape though. I'll say it relates to real life. It gets quieter, but that's obvious. What else can we say in grade 10 that's fair? That might be about it. That's conclusion. That's it. That was too long. Sorry, but you heard me ramble. So these are the same things that you need to think about. So me rambling and me kind of searching was hopefully a model for you. Took too long? Such is life.